this is the last unit, this is the last lesson in Unit 3, and it involves putting combinations together with probability. And, again, like we've done up till now, just sort of putting different aspects of the math together. So remember, theoretical probability, the probability of an event A happening, is the total numbers of ways that A could happen, which is n of A, divided by the total number of possible outcomes, successful or unsuccessful, the size of the sample space. Also remember, in this unit we've been talking about combinations, and remember combinations are the number of ways something can happen where order doesn't matter. So n is the number of things that we choose from, and r is the number of things that we're choosing for NCR. And combinations are calculated using the formula n factorial divided by n minus r factorial times r factorial, right? So that's the other formula we're going to need to use today for probability. So we're going to put those two things together. And so I'm just going to go through a series of examples to show you how that could work. So the first example, a scratch and win contest at a store allows you to scratch 5 numbers. So there's 5 numbers that we have to get. If all of your numbers match, the winning set of 5 numbers chosen from 1 to 25, that's important. Without regard to order, also important, because if order doesn't matter, that makes it combinations, then you win the grand prize. So we want to find out what the probability of winning the grand prize is. So if we let event A be grand prize, then the probability of A happening is going to be, we have to get 5 out of 5 numbers correct. So there's only one way to do it, but we could show that with combinations as well. There's 5 correct numbers, and we have to get all 5 of them. So we have to do 5 choose 5, which equals 1 anyway. As far as the number of ways that the numbers could come up, though, there's 25 numbers to choose from. And of those 25 numbers, we still have to get the 5 correct ones. So if we put that into our calculator, what we'll see is that 5 choose 5 equals 1, and that 25 choose 5 equals 53,130. So that's it as a fraction. If we want to change it to a decimal, then that's going to be equal to 0.0000188, or approximately 0.002%. Okay, so pretty unlikely that you are going to win the grand prize if you have to get 5 out of 25 numbers. And we've already seen 649 means you have to get 6 numbers right out of 49. So I think the probability for that was something like 1 out of 14 million. So you're better off saving your money when it comes to 649. To win second prize, 4 of the 5 winning numbers must match. So we don't have to get all 5 now, we just have to get 4 out of the 5. What's the probability of that? All right, well, let's call that event B. If we only have to get 4 out of the 5 numbers, that means that there's more ways to win, right? So it's likely, or it's logical, that our probability would be higher. So we have to get 4 out of 5 numbers correct, so that's 5 choose 4. Remember, we still have to choose 5 numbers, though. So if 4 of them have to be correct, that means that 1 of them has to be incorrect. So how many incorrect numbers are there? If there's 25 numbers altogether and 5 of them are correct, that means that 20 of them must be incorrect, and we have to choose 1 of those. So it's 5 choose 4 divided by 20 choose 1. Sorry, not divided by, times 20 choose 1. What we're going to divide by, again, is 25 choose 5. That doesn't change. It's always 25 choose 5 for this particular contest. And when we do that, 5 choose 4 equals 5, and 20 choose 1 equals 20. So when we put that together, there's actually 100 ways to win second prize. And again, the bottom doesn't change, so we've got 100 times greater probability of getting second prize. So it'll be the same answers, except that we're going to have to take away a couple decimal places. So now it'd be 0.0018 as a decimal, or 0.2%. Again, not looking super good even for second prize. All right, second example. A university committee of 8 people is to be formed from 16 students. So we need to get 8 people. That's going to be our R value. From 16 students and 10 professors. Each person is equally likely to be chosen, so it's random. That's what we're being told here. And it's a committee, so since it's a committee, order doesn't matter. We're going to use combinations again. What is the probability that there's an equal number of students and professors? Well, in this case, since there's 8 people altogether, that, to put specific numbers on there, that means that there's going to have to be 4 students and 4 professors, right? So again, we have to put numbers onto things. 4 of each. So if we call that event C, then probability of event C happening is we need 4 of the 16 students. So 16 choose 4, or order doesn't matter. We need 4 of the 10 professors. And there's a total of 26 people, right? And everyone's equally likely to be chosen. So we also have to consider that as well. So there's 26 people. It could be all professors, it could be all students, it could be any combination. So we have to, that would be our sample space. So it's 26 people, and we're still choosing 8 of them altogether. So when we put that in our calculator, it turns out that we have a numerator of 382,200, a denominator of 275, which works out to 0.2456, or about 25% approximately. It's about a 1 in 4 chance that there's going to be an equal number of students and professors. What's the probability that there's going to be at least 6 students chosen? Well, we got that word "at least" in there, or those 2 words, "at least" in there again. Remember, that signifies to us that we have to consider multiple cases. When we see "at least," we want to consider, should we go at it directly or should we try an indirect method? And the answer is, we're going to take the one that's the least work. So here's how we decide. There's going to be 8 people on the committee, and we want at least 6 students. So directly, we could figure out what's the probability of having 6 students, or 7 students, or 8 students. If we wanted to do it indirectly, then we would have to find the total number of ways to do it and subtract all the ways of doing 0 students, 1 student, 2, 3, 4, 5 students. So there'd be more work to do it indirectly. So we want to come at this one directly, all right? We'll call this event D. Switch back to blue. All right, so the probability of D, event D happening, is going to be, I can do the probability all at once. So again, what's the probability of having exactly 6 students? Well, exactly 6 students, there are 16 students, and we want 6 of them, so it's 16 choose 6. Which means that there's 2 other committee members that would be professors. So out of the 10, we need 2 of those. And then we figure out, we add on there the number of ways that we could have exactly 7 students, right? And if we have exactly 7 students, then that means that we're going to have 1 less professor, and so there's only going to be 1 out of the 10. So it's going to be 16 choose 7 times 10 choose 1, and then finally we could have 8 students, so 16 choose 8, and 10 choose 0. So 6 students, 7 students, 8 students, those are the only possibilities. And again, the sample space doesn't change, so it's still 26 choose 8. When we do those numbers, what I got was, for getting exactly 6 students, there are 360,360 ways to do that. There are 114,400 ways to get exactly 7 students, and there are 12,870 ways to get exactly 8 students. And again, the numerator is going to stay the same. It's 1,562,275, which works out to 0.3121, or about 31%. It's about a 1/3 probability that you'll have at least 6 students chosen. Last one involves Plinko boards. Now remember, we've recently been talking about Pascal's triangle, and when it comes to Plinko boards, then we want to use the concepts we've learned for Pascal's triangle. So in this one, the object of the game is to get 6 points in 2 turns. So we have to consider the fact that there's going to be 2 turns going on. So probability of winning the game, is it a fair game? We'll get to those in a bit. But the first thing we need to do is find out our probabilities for 1 round of the game. So for a single turn, then we can move on from that. So remember, using Pascal's triangle, we start with 1 at the top, so there's only 1 way they can drop this ball in here. Oops, switch to my blue pen. So there's only 1 way to drop that there. There's only 1 way that they can get to, that the Plinko ball or disc can get to that spot. There's also only 1 way that the Plinko disc can get to that spot to the right of where it started. And then it goes down following Pascal's triangle. There's 1 way to get here. There's 1 way to get to this outside one here. But this middle one that I wrote a 2 in, there's 2 ways to get to it. You can visually see or imagine the disc going to the left and then to that spot with a 2 in it, or to the right and then to that spot with the 2 in it. So there's 2 ways to get to it. And so if we follow Pascal's triangle, remember we add up the numbers, and so we get 1, 3, 3, 1. We get 1, 4, 6, 4, 1. For this one, adding, we get 5, 10, 10, 5. So now it's not true Pascal's triangle anymore. It's changed slightly, but still using that concept. There's 5 ways to get here to the 2. There's 15 ways to get to the 0, 20 ways to get to the 4, 15, and 5. So these numbers here are the ones that we need to be looking at. So in total, on 1 round, there are, well, let's do the probability, I guess. Probabilities for 1 round, okay? So the probability of getting a 2 is going to be, there's 5 ways to get to the 2 on the left, there's 5 ways to get to the 2 on the right, and if we do the total number of paths, if we add everything up, 5 plus 15 plus 20 plus 15 plus 5 equals 60. So there's 60 different paths that that ball could take. So if there's 5 ways to get to the one on the left and 5 ways to get to the one on the right and 60 altogether, that means there's a 1 in 6 chance for a single round to get a 2. And then doing the same thing for getting a 0, just to go from left to right. Well, there's 15 ways to get to the 0 on the left, 15 ways to get to the 0 on the right, still out of 60 paths. So that gives me 30 over 60, which reduces to a half. And the probability of getting a 4, there's only the one space, and that is 20 ways to get to it, so 20 over 60, or 1/3. All right, so that's for one round. Now we have to get this part about getting 6 points. If you're going to play 2 rounds, how are you going to get 6 points? Well, if you're going to get 6 points, if you got a 0 on the first round, you're out of luck, right? Because the second round, you'd have to get 6 points on the second round just to win, and there's no way to get 6 points on the second round. So if you got a 0 on the first round, game's automatically over. If you got a 2 on the first round, then you'd have to get a 4 on the second round. There we go. 4 on the second round. That would add up to 6, right? 2 and 4. 2 followed by 4 gives you your 6 points. Well, we've seen the probability of getting a 2 is 1/6. The probability of getting a 4 is 1/3. And we have to get both of them, right? It's 2 and 4. And we know that and means multiply. So 1/6 times 1/3 equals 1/18. And then we have to consider what happens if we get a 4 on the first turn. Well, there's two ways we could win if we get a 4 on the first turn. We could get a 2, because that would still get us 6 points. And so then again, we'd have a 4, 1/3 probability of getting a 4, a 1/6 probability of getting a 2, which is again 1/18. And finally, if we got a 4 on the first round, and we could also get a 4 on the second round, because I'm going to take it to imply that you need at least 6. So if you got 8 points, you still win. So you got a 1/3 probability of getting a 4 on the first round, and a 1/3 probability of getting a 4 on the second round, and that's going to equal a 1/9 probability overall. So the last thing we need to do to answer this question, these are all ways we could win, but we can't do all of them at once. Either we could get a 2 or a 4, and a 4. We could get a 4 and a 2, or we could get a 4 and a 4. So we would add these probabilities all together. So the total probability would be 1/18 plus 1/18 plus 1/9. If we, I guess the easiest way to do that is to just change it to a decimal, and if I do that, I get approximately equal to 0.22, which is 22%. And the last question to go along with this was, is this a fair game? The answer is no, not a fair game. If it was a fair game, then you would have a equal probability of winning and losing. So the probability of winning would be 50%. It's not. That's it for this lesson.